Let's go ahead and start a review on mass to mole conversions and moles to particles conversions by looking at the roadmap that we've used previously. So recall that whenever we're converting between mass and moles, we need to use the molar mass to make these conversions. So if you're going from mass to moles, you're going to have to divide by the molecular weight. So we're able to cancel out those units of grams and obtain units of moles. Just like if you were to go from moles to grams, you're going to have to multiply by the molecular weight. Now, if we're trying to go from moles to particles or particles to moles, we're going to have to use Avogadro's number. And recall that Avogadro's number is a constant, so this is true regardless of the identity of our species. And this has units of particles, atoms, molecules, ions, or formula units per mole. So it tells us how many of those entities there are in a single mole. So if we're trying to go from moles to particles, we will multiply by Avogadro's number. Whereas if we're trying to go from particles to moles, we will have to divide by Avogadro's number. So Avogadro's number is a constant and will be true regardless of the identity of the system. But whenever we're looking for going between mass and moles, we may have to calculate the molecular weight. So let's go ahead and try a few practice problems where we look at going between the mass and number of particles or particles and the mass. And before we get to our final answer, we will have to convert them to moles. So first up, let's assume that we're looking at a system of caffeine, which has a chemical formula of C8H10N4O2. The molecular weight is 194.22, and we're going to use units of grams per mole, since we're looking at more than a single molecule. And what we want to do is we want to find out the number of molecules in 95 milligrams of caffeine. And this is the typical amount of caffeine in a cup of coffee. So there's a few things that we would have to do before we got going on this problem. The first is we would have to convert milligrams to grams. So we would have to use the conversion factor of 1,000 milligrams in 1 gram, or we'd have to know that there are 0.001 grams in a milligram, and both of these statements are equivalent. The other thing that may be required of you is to find the molecular weight. So if that's not given to you, recall that you would just take the number of carbon atoms, so we have 8, multiply it by the atomic weight, which is 12.01 grams per mole, plus the number of hydrogens. So in this case, there are 10 hydrogens, so we have 10 times 1.01 grams per mole, plus our 4 nitrogens times 14.01 grams per mole, plus 2 oxygens, each at 16.00 grams per mole. So you'd have to go through, and it would be expected that you could look these values up on the periodic table yourself, show your work, and then multiply those through and find out what the actual molecular weight is. But now that it comes time to actually converting, we need to look at what our given is and figure out how we are going to go through and calculate the number of molecules. So in this case, our given is the 0.095 grams of caffeine. So we'll start by writing that out. 0.095 grams. And then I'm going to just use the label of CAF for caffeine. So from here, what we want to do is we're trying to find the molecules. But recall that we can't go directly between mass and particles. So the first stop we have to make is to go to moles. So in order to go to moles, we are going to have to use the molecular weight. So we'll always use the molecular weight to go between grams and moles. So to get our units to cancel out, we're going to put the 194.22 grams of caffeine in the denominator and the 1 mole of caffeine in the numerator. And what we'll see here is that the units of grams of caffeine will cancel out, and we're left with moles. It's really important to remember that moles is not equal to molecules. So we aren't done yet. So now that we're in moles, we're going to have to continue on to particles and figure out how many molecules there are. So we will use Avogadro's number. So we'll put 6.022 times 10 to the 23rd molecules of caffeine in the numerator. 1 mole of caffeine in the denominator. And we'll see that moles of caffeine cancel out completely. And we should be left with units of molecules. And whenever we plug this in our calculator, what we should get is, let's see, 2.95 times 10 to the 20th molecules of caffeine. So you have to make sure that you include that factor of times 10 to the whatever power it is. You have to include the order of magnitude, because if you think about this, if we just wrote down 2.95 molecules of caffeine, well, you can't have a fraction of a molecule. It must be an integer. All right, so now that we've gone from mass to molecules, let's try going the other way. This time, let's go between molecules and grams. So in this case, let's assume that we have 3.01 times 10 to the 23rd molecules of water, and we are trying to find out how many grams of water are present. So since we are going beyond moles and we're trying to find the grams, that tells us right away that we're going to have to calculate the molecular weight. So the molecular weight for water, we have 2 hydrogens, each at 1.01 gram per mole, plus 1 oxygen at 16 grams per mole. And we're going to end up with 18.02 grams per mole. So let's go ahead and start by writing out our given and figure out what we need to do first. So we have 3.01 times 10 to the 23rd molecules of water. So what we're going to try to do now is we need to convert from molecules, and we can go from molecules to moles. So in this case, moles will go in the numerator, and we're going to have to divide by Avogadro's number. So 6.022 times 10 to the 23rd molecules of water. Then we'll see that our molecules of water cancel out. We're left with units of moles. And since we're trying to go to grams and we're in moles, we're going to have to multiply by the molar mass of water. So we'll multiply by 18.02 grams of water divided by 1 mole of water. We'll see that the moles of water will cancel out. We'll be left with grams. In this case, whenever we plug it in our calculator, again, we want 3 significant figures in our answer. We will end up with 9.01 grams of water. So make sure you're practicing plenty of these conversions, and you want to get away from using our roadmap as we're going, because this will not be given to you on a test. You just want to be able to know that if you're going between mass and moles, you need to use a molecular weight. But you have to figure out whether or not you're going to multiply or divide based off your given. And the same thing whenever you're going from moles to particles, atoms, molecules, ions, or formula units. You're going to have to use Avogadro's number, but you're going to have to figure out whether you need to multiply or divide depending on which direction you're going.